You know, when you're running a high-stakes drone operation, the entire mission can fail in a single instant. And the number one cause? A weak video link. Having a stable, long-range, interference-proof connection isn't just some nice-to-have feature, it's literally the difference between mission success and catastrophic failure. So let me ask you this. When you push your current drone systems to the absolute edge, what's the first thing to give out? For so many operators, it's the communication system. The signal gets weak, the video starts to glitch or cuts out completely, and just like that, the mission is compromised. All right, here's how we're going to break this down. First, we'll talk about the current limits of drone video transmission. Then, we'll dive into the core innovation from Semix that just shatters those limits. We'll look at the hardware, see how it stacks up against the competition, and finally, explore what all this means for your next operation. Okay, let's really frame the problem here. Why do so many systems just fall apart when you push them beyond a simple, routine flight? The whole industry is moving to digital, right? But most solutions are still hitting a hard wall. They've become a total bottleneck. They're held back by limited range, they get absolutely crippled by interference in crowded radio environments, and they just can't reliably handle the crystal clear HD video that today's missions demand. And that brings us to the foundation of what makes Semix so different. Look, this isn't just a small, incremental improvement. We're talking about a fundamental leap in the technology itself. This really gets to the heart of it. While the hardware itself is impressive, the real game changer isn't the drone. The core advantage, the breakthrough, it all starts at the silicone level. It's all in the chip. To be specific, we're talking about a proprietary system on a chip, or an SoC. Think about it. By integrating all the critical pieces, the baseband processor, the radio frequency components, the communication protocols, all onto a single piece of silicon, you get a level of performance and efficiency that you just can't get by piecing together separate components. Let's just run through the specs here, because they're pretty incredible. This is the world's first RISC-V-based SoC, designed for full band operation. That means it covers everything, from 150 megahertz all the way up to 7 gigahertz. It's powerful, it's scalable, and it has super low power consumption, which is perfect for these compact, high-performance drones that need to be efficient without cutting corners on capability. So let's shift gears from the chip itself to the actual hardware. Let's see how this foundational tech gets deployed out in the field. Okay, so Semix has two main modules built on this SoC. First step is the broadband module. This will give you over 15 kilometers of range and speeds up to 160 megabits per second, and it operates on those standard 2.4 and 5.8 gigahertz bands. But for the ultimate performance, you've got this single frequency module. Now we're talking over 30 kilometers of range with data rates blasting up to 200 megabits per second. And it does this on the super stable 1.4 gigahertz band, which is way less crowded and much less susceptible to interference. Yeah, just let that number sink in for a second. A standard transmission range of over 30 kilometers. This completely changes what's possible for line-of-sight missions. We're talking long-range surveillance or infrastructure inspections that were just flat-out impossible before. And you're getting that incredible range with a peak over-the-air data rate of 200 megabits per second. This is the kind of bandwidth you need for a perfectly clear, high-def video feed without any of those ugly compression artifacts. It ensures you never, ever miss a critical detail. And beyond just those headline numbers, this system is built tough for mission-critical reliability. We're talking latency under 10 milliseconds, an operational temperature range that goes from a freezing -40 all the way up to 85 degrees Celsius, and flexible networking topologies, all built on that proven 4th-gen R8032S chipset. So this is the big question, right? How do all these amazing specs translate into a real-world, can't-be-beat competitive advantage? The answer is right here. This is the single most powerful, exclusive advantage Semix has: wideband adapter frequency hopping. You see, unlike other systems that are just stuck on those crowded 2.4 and 5.8 gigahertz highways, Semix can intelligently and automatically hop across the entire spectrum, from 150 megahertz to 7 gigahertz, to find the clearest, most robust channel available. This is the absolute key to operating in dense urban areas or contested airspace. Let's put it head-to-head. While competitors are stuck on dual band, Semix is using the entire wideband spectrum. Where they might reach 30 kilometers, Semix can push all the way to 50 under the same conditions. And this massive advantage all comes from that in-house SoC, not from using standard off-the-shelf parts like everyone else. And that right there is the key takeaway for the future.
Owning the core technology isn't just about how great it performs today. It means Semix has this enduring, untouchable advantage for future development. They've got a roadmap for continuous expansion and performance upgrades.
So, what does this all actually mean for you, the person flying the drone? How does this technology completely redefine what's even possible?
Let's just quickly recap the crucial points. First, you get unmatched range. We're talking 30 kilometers plus, even up to 50. Second, you get unrivaled anti-interference thanks to that exclusive wideband hopping. Third, high-performance data rates for flawless HD video. And fourth, and this is the most important, it all comes from a foundational technology advantage, that proprietary SoC.
At the end of the day, it all comes down to this one simple idea. The potential of your mission, how far you can go, the data you can gather, is no longer being held back by the limits of your connection. That bottleneck, it's gone. This kind of tech doesn't just make current missions better, it makes entirely new missions possible. So it really just begs the question, and this is what we'll leave you with. When your communications are no longer the thing holding you back, what will you build? What missions will you fly?